Okay, so this is section 4 of chapter 6, and in this section, we will discuss threats to internal validity. All right, so let's begin by discussing the concept of extraneous variables. Now, an extraneous variable is a variable that exists in the study, but is not officially a part of the study. It was not put there by the scientist. It is not being investigated by the scientist, and it plays no role in the research question or the hypothesis. So let's consider some examples. Um, there could be participant characteristics like personality traits that are extraneous variables to the study, especially if the study has nothing to do with personality. Or these can come in the form of external or environmental factors. For example, the temperature outside, or the time of day, or the day of week. Okay, these are all extraneous variables, variables that are not relevant to what you are examining in the study, or these shouldn't be relevant. Now, these extraneous variables can become a problem if they interfere in your study and contaminate your measurements by affecting the variables that you are interested in measuring. So a confound or a confounding variable is an extraneous variable that can distort and compromise your research findings by providing an alternative explanation for the proposed relationship between the variables that you are studying. So typically, a confound is a variable that changes systematically with the variable being studied. And we'll look at some examples of this in just a few slides. Now, this can create serious problems because if you have a confound that offers an alternative explanation for your results, it threatens internal validity. Suddenly, you can't say with any certainty that your results are being caused by the hypothesized relationship between the variables that you're studying. It could be caused by this other explanation. So what's to be done? Well, to minimize the impact of confounds, you can employ careful study design, random assignment, controlling for known confounding variables, and using various statistical techniques that are designed to minimize the impact of confounds. And throughout the course, we'll revisit some of these ideas in greater detail. So let's consider this hypothetical data set. And I used a similar example earlier. But here, the researchers are testing the effects of music on problem solving. So people are given various problems to solve while listening to different kinds of music. And so in this study, we have two variables. One is problem solving, which is what is being measured, and those are the numbers plotted in the three columns. Now the other variable is music. What music will people hear when solving these problems? And this variable will be broken down into three conditions. So the three conditions are as follows. Firstly, a control condition where people solve problems without music in complete silence. Then in the middle, you have the unpleasant condition when people solved problems while listening to something unpleasant, aggressive music, something jarring. Use your imagination. And finally, in the right column, you have the pleasant condition when people solved problems while listening to calming, relaxing music. All right, and so the question is, is there a relationship between music and problem solving? And if we look at the scores in these three columns, you may notice something of a pattern. And to make it easier, I've created a bar graph. Here it is. Here's the bar graph, where each bar is the average of one of the three columns. All right, so all the way on the left, you have the performance in the control condition. That's the no music condition. That's the baseline. Now, in the middle is what happens to people who listen to the horrible, aggressive music. And you can see their performance goes down. It's lower compared to baseline. And now, what about people that listen to the calm, pleasing music? Well, their performance is all the way on the right, and you can see their performance seems to be higher than the other two groups. So it would appear on the surface that music makes a difference. It would appear that there's a relationship between music and problem solving. That music can either help or hinder problem solving abilities depending on the genre of music. Okay, great. Now let's consider some hypothetical confounds that could arise if this study were poorly designed. All right, let's say, for example, that these three conditions were carried out for some reason in different rooms. And maybe the room with the aggressive music was much colder than the other two rooms, or the walls were some ugly color, or there was a bad odor, some musky odor in that room. Well, that could be a serious confound, because that can offer an alternative explanation as to why people did worse in the aggressive music condition. Maybe it has nothing to do with the music, maybe it's something about the room that hindered their performance. Okay, let's consider another hypothetical confound. What if the measurements for these three conditions were collected on different days of the week? So maybe aggressive music data were collected on Monday, the control data on Wednesday, and the calming condition data on Friday. Well, that also could be a confound, because maybe the day of the week is causing the difference in performance and not the music. And maybe people are more relaxed on Fridays, and so they do better at these problems than they do on Monday, right? That's a confound. Or imagine that your groups are different from each other in some way. So let's imagine that maybe math majors and engineers are overrepresented in your calming group compared to the other two groups in the calming music group. And let's say that your measure of problem solving contains problems that have quantitative reasoning, the sorts of problems where a math major or an engineering major might excel. This would be a very serious confound, because now you don't know, is the better performance in the calming music group caused by the music or by the fact that the people in that group are better suited to solve those types of problems. All right, so these are all just a small sample of the sort of confounds that could arise in a study that is maybe poorly designed. So let's formally define the different categories within which confounding variables can be found in. And those three categories are as follows: environmental variables, participant variables, and time-related variables. All right, so first, environmental variables. And these are variables that have to do with factors related to the environment. And this can be a problem if environmental variables differ systematically between your conditions. So we provided an example of this in the music study, right? So imagine that the 3 music conditions are run in 3 different classrooms. And maybe those rooms differ in terms of their lighting or temperature or noise or smell or any number of other features. And so this, of course, creates a serious potential confound. So to deal with this issue, you want to make sure that there's consistency across all of your conditions. You want to make sure that your conditions are all occurring within the same environment to avoid confounds related to environmental variables. Next is the issue of participant variables. And so when you are comparing different groups comprised of different individuals, you always want to make sure that those groups are as similar as possible. Because if there are any systematic differences between your groups in terms of participant characteristics, then any differences that you measure between those groups may be due to the differences between the participants in those groups and not the variables that you are manipulating. So we considered an example of this in the music problem-solving study. So again, let's say you have people solve problems that require quantitative reasoning. And let's say for some reason, in one of your conditions, you have a bunch of math majors, but not the other conditions. Well, obviously, this is a big problem because that group may do much better, not because of the music, but because the people in that group have the necessary experience for solving those types of problems. And of course, this is a serious confound. Of course, it creates ambiguity as to the cause of your findings. And so one way of minimizing this problem is to make sure that you use random assignment to distribute your participants into groups and that each group is large enough. And finally, time-related variables can be confounding as well. So time-related variables are variables that accumulate or change over time. And this is especially a problem if you're using what is called a within-subject design, in which the same group of people undergo multiple conditions or multiple treatments. So in the music problem-solving example, there were 3 different groups, 1 group per condition, comprised of different individuals. Now let's imagine that a different version of that study were conducted, such that there was only 1 group of people, and that 1 group undergoes all 3 conditions in that study. And so imagine the following design. On Monday, these people come in and they solve problems while listening to aggressive music. And then the same people come back on Wednesday and solve problems in the no music condition. And the same people come back on Friday and solve problems in the calming music condition. And suppose you find once more that the calming music condition is associated with the best performance. Now, one explanation is that the music is affecting performance, but of course, you have a serious confound. What if the difference is driven by practice effects? After all, the calming music condition is on Friday, and by this point, people have acquired a lot of experience solving these problems. This is the 3rd time that they're performing this task. So maybe the experience, maybe the practice is really driving the improvement that you see, and it has nothing to do with the music. So this is an example of a time-related confound. And one way of dealing with such confounds is to use what is called counterbalancing. And we'll talk more about counterbalancing in later chapters, but the basic idea is to ensure that people do not go through your conditions in exactly the same order. So for some people, the calming condition should be on Monday. For some people, it should be on Wednesday. For some people, it should be on Friday. It should not be the same order. The order should be shuffled across all the people. All right. So that covers threats to internal validity, and I will see you at the next lecture.